Welcome to the deep dive. Today, you're joining us as we travel way back in time.
Way, way back.
Exactly. We're exploring Asiaceratops. That means Asian horned face, which is pretty cool.
It is, yeah. A dinosaur genus with, well, some interesting stories and maybe a few question marks.
Right. So our mission today is basically to unpack what we know, digging into the science, the classifications, descriptions, the research papers.
It bring you the key stuff, the fascinating bits.
You want to get the knowledge without getting totally lost in the weeds, so let's just dive right in.
Let's do it. Asiaceratops. It's a great example, really, of these early Asian horned dinosaurs. The name itself, like you said, Asian horned face.
Tells you a lot up front.
It does. Location and group, right there. It's almost like a headline from the Cretaceous.
Okay, let's unpack that headline then. The first species they found, Asiaceratops salsopaludalus. That second part, salsopaludalus, that means something too, doesn't it?
It does, yeah. It's Latin, basically means of the salt marsh.
Yeah.
And that little detail, it gives us a clue about the environment where those first fossils were found, in Uzbekistan.
So maybe a salty, marshy kind of place. That's quite specific for 99 million years ago.
It paints a picture, definitely.
So how did this salt marsh Asian hornface first pop up on the scientific radar?
Well, the holotype, that's the key specimen they used to define the species.
Right.
That was discovered back in 1989 in Uzbekistan, like I said, by Levnesov, L.F. Kaznishkina, and Geo Cherepanov.
A team effort.
Absolutely. And this specific fossil catalog number, CCMGE 912457, it came from the Kozakul Formation.
And that formation tells us the age.
Exactly. It's from the early Cenomanian stage.
Yeah.
So that puts it around 99 million years ago, give or take.
Wow. Late Cretaceous, then. It's hard to even picture that world.
Almost impossible, yeah. And that first find, it was just a starting point, really.
What did they actually find initially? Was it a whole skeleton?
Oh, no, not at all. It was just part of a left maxilla, the upper jawbone.
Just a fragment. Okay.
Yeah, but even a fragment like that can hold, vital clues, how it differs from other dinos, stuff like that.
And they found more later.
They did. In 1995, Nassau described more fossils also assigned to A. salsopaludalus from 3 different spots in Uzbekistan, actually.
Ah, so building the picture.
Right. This later stuff included more skull bits, teeth, even a phalanx, a toe bone, and part of a humerus, the upper arm bone. And importantly, these bits seem to come from dinosaurs of different ages.
So young ones, older ones, giving us a snapshot of their lives.
Pretty much, yeah.
Okay, so that's A. salsopaludalus. But it's not the only Asiaceratops, is it? There's another species.
Correct. There's a second one, Asiaceratops sulcidans.
Sulcidans, okay.
And the interesting thing here, the twist, is that it wasn't originally called Asiaceratops at all.
Oh, what was it called before?
It was first named way back in 1953 by a paleontologist named Bolin. He called it Microceratus sulcidans.
Microceratus, so small-horned.
Something like that, yeah. It wasn't until that same 1989 paper, the one describing A. salsopaludalus, that Nessoff and his team looked again at Microceratus sulcidans and said, hang on, this actually belongs in our new genus, Asiaceratops.
Huh. So they reassigned it. Why do scientists do that? What does that tell you about, the process?
Well, it shows science is always refining things, right? As we find more fossils or re-examine old ones with new knowledge, we sometimes realize our earlier classifications weren't quite right. We see new connections.
Makes sense. So what made them think Microceratus sulcidans was actually an Asiaceratops, and where was that one found?
The fossils for A. sulcidans, the ones Bolin first described, they came from early Cretaceous rocks, so a bit older than A. salsopaludalus.
Okay, how much older?
We're talking Aptian-Albian stages. And these were found in China, in the Chiminpu group, and also in Mongolia.
So China and Mongolia for the older one, Uzbekistan for the younger one, different times, different places.
Exactly. And the original material for A. sulcidans, the holotype, included, let's see, a couple of teeth, some vertebrae centra, part of a tibia that's a lower leg bone, some ankle bones, the tarsals, and a left foot, the piece.
Still pretty fragmentary, but different parts than the first species holotype.
Right, different pieces of the puzzle.
So if we put these two species together, what's the total time range for the Asiaceratops genus?
Well, you've got A. sulcidans in the early Cretaceous, and then A. salsopaludalus later in the late Cretaceous, specifically the early Cenomanian. So the genus spans, quite a chunk of the Cretaceous period.
That's significant. It shows these early horned dinosaurs were around in Asia for a good long while.
Definitely.
Okay, let's zoom out a bit. How does Asiaceratops fit into the grand scheme of things? The dinosaur family tree.
Right, the classification. So big picture, Eukaryote animal, chordate,
It's
dinosaur.
a standard hierarchy.
Yep. Then within dinosaurs, it's an ornithischian, one of the bird-hipped dinosaurs. And within that group, it belongs to the ceratopsia.
The horned dinosaurs.
Exactly. Though these early ones didn't necessarily have big horns like, say, Triceratops, but they had the characteristic parrot-like beak, mostly herbivores.
And they were big in North America and Asia during the Cretaceous, right? Before the big extinction event.
That's right. They thrived then.
Yeah.
But all ceratopsians, well, all non-avian dinosaurs, vanished about 66 million years ago. Asiaceratops sits within a subgroup called Neoceratopsia, the sort of more advanced ceratopsians compared to the very earliest forms.
So an early Neoceratopsian from Asia. Got it. Understanding these relationships helps us trace their evolution, doesn't it?
Absolutely. It's all about figuring out who's related to whom. And with Asiaceratops, its exact spot has been, well, a little debated.
Oh, how so?
Well, Nisov himself, back in 95, he thought it was distinct enough to warrant its own subfamily, Asiaceratopsinae.
Okay.
But when other scientists run these big computer analyses, phylogenetic analyses, trying to map out the family tree, the results haven't always agreed.
What did they suggest?
Some early studies hinted it might be a basal member of the Leptoceratopsidae family, another group of early ceratopsians.
Right.
But more recently, several studies have pretty consistently placed it outside Leptoceratopsidae. They see it as a more basal Neoceratopsian overall, but not specifically a Leptoceratopsid.
So still an early Neoceratopsian, just maybe not in that specific family brand.
Exactly.
Yeah.
It just shows that figuring out these relationships, especially with fragmentary fossils, is tricky. It's an ongoing discussion.
Which actually brings up something else I read, the term nomen dubium. That's been applied to Asiaceratops, hasn't it? What does that mean?
Ah, yes. Nomen dubium. It's Latin. Means doubtful name.
Doubtful name. Why doubtful?
In paleontology, we use it when the original holotype specimen, the one the name is based on.
Like that jaw fragment for A. salsopalidolus?
Precisely. When that specimen is so incomplete or doesn't have enough unique diagnostic features, it becomes really hard to say for sure if it's truly distinct, or if other fossils found later definitely belong to the same species.
So the jaw fragment might not be enough to uniquely define Asiaceratops.
That's the concern some researchers have raised, yeah. Is it distinct enough? Can we confidently assign other fossils to it? It leads to instability in classification. So some consider it a nomen dubium.
Is there any way to resolve that?
Well, there is potentially a piece of basic cranium, it's the base of the skull, that Nisov tentatively referred to Asiaceratops. Some think that fossil might, just might, show some unique features that could help solidify the genus's validity.
Ah, so maybe more evidence will clear things up. A bit of a paleontological cliffhanger.
Kind of, yeah.
Okay, whether its name is doubtful or not, we know it was a ceratopsian, so...
It ate plants, right?
Yes, definitely herbivore, like all ceratopsians.
What kind of plants would it have been munching on back then, nearly 100 million years ago, in, say, Uzbekistan or China?
Well, you have to remember the world was different. Flowering plants, angiosperms, the plants that dominate today, they were around, but not nearly as widespread or diverse, especially in the early to mid-Cretaceous.
So, less grass, fewer flowers. Much less, yeah. The dominant vegetation would have been stuff like ferns, cycads, which look a bit like palms and conifers, like pine trees.
So a different kind of salad bar.
A very different salad bar.
Yeah.
And Asiaceratops with that sharp ceratopsian beak.
The parrot beak?
Right. It would have likely used that beak to snip off tough leaves or maybe needles from those ferns, cycads, and conifers.
Makes sense. Now, you mentioned several key papers and researchers. Can you just quickly recap the research trail that built our understanding of Asiaceratops?
Sure. It really starts with Boland's 1953 report, which first described the fossils that would later become A-sulcidans.
Even though he called it Microceratus.
Right. And the pivotal one is Nasov et al.'s 1989 paper. That's where A. salsopalidolus gets named, and Microceratus sulcidans gets moved over to Asiaceratops.
Right.
Nisov followed up with a big book in 1995 on dinosaurs of northern Eurasia, including more details. Then you have important reviews like the chapter by Ewan Dodson in the big Dinosauria book, the second edition from 2004, putting basal ceratopsians in context.
Right, broader context is key.
And papers discussing related dinosaurs often mention Asiaceratops, like Makovicki and Norell's 2006 paper on Yamaceratops. And then, like we discussed, the more recent phylogenetic analyses, Morshauser and colleagues in 2019, Sun et al. In 2022, Tanaka et al. Just this year, 2024, these keep refining its position on the tree using new data and methods.
So it's a real cumulative effort over decades.
Absolutely. Science building on itself.
Okay, so let's try and pull this all together. What are the main things we should take away about Asiaceratops from this deep dive?
Well, I think first, it's an important early horned dinosaur, a ceratopsian from Asia.
Yeah.
It gives us a glimpse into their evolution on that continent.
Okay, early Asian representative.
Second, there are two species currently recognized. A. salsidens from the early Cretaceous of China and Mongolia, and A. salsopulidales from the late Cretaceous of Uzbekistan. Different times, different places.
Got it.
Third, its exact evolutionary placement is still a bit fuzzy. Most recent work suggests it's a basal neoceratopsin, but probably not a leptoceratopsid, and there's that whole nomen dubium question hanging over it due to the fragmentary initial finds.
Right, the uncertainty.
And finally, it was a herbivore, using its beak to eat the dominant plants of its time, likely ferns, cycads, and conifers, in environments that might have included things like salt marshes.
Fascinating stuff. Piecing together a creature from fragments found millions of years later. Which leads to a final thought, maybe, for you listening.
Yep.
Given that our picture of dinosaurs like Asiaceratops often relies on, well, incomplete evidence, how might future discoveries, maybe in parts of Asia that haven't been fully explored yet, completely change our understanding? Could we find fossils that rewrite the early chapters of horned dinosaur evolution or even other major dinosaur groups?
It's entirely possible. That's the exciting thing about paleontology.
It really is. It's a constant process of discovery. Well, thanks for taking this deep dive into the world of Asiaceratops with us.